Hello, Math 1050. Mrs. Bricky here, and this is section 2.3 on functions and relations. In math, anytime you have a set of pairs, an ordered pair set, that's called a relation. So, for example, um, points are relations. So, like if you have an x value that has a y value with it together, that's a relation. Uh, for a relation, all of the x values comprise the domain of the relation, and all of the y values, or the second value, second position, that's the range of the relation. Most of the time in math, we are studying functions, which are relations that have one additional specific characteristic. It's not just a set of ordered pairs, but if the relation has each value in its domain associated with exactly one value in its range, that's a function. And that's what we deal with most of the time. So your first topic in section 2.3 is to identify functions when you're given a bunch of different relations. So I have 4 relations here. The first 2 shown are mappings, and then we've got a table and a list of points for our 4th relation. So we just need to decide function or not a function. So because here's our input, because our input is associated with more than one output, this one is not a function. But on the second mapping, since each of these domain values is only associated with one range value, this one would be a function. For both a table and a list of points, what you're looking for is repeated domain input values. So like desk got repeated here by virtue of having multiple arrows. In our table k, the domain value k got repeated. So that would be not a function. So it doesn't matter that the 8 showed up twice. It matters that k shows up twice, and it matters that g shows up twice. For a list of points like this, again, we're just looking to see if any of our inputs got repeated with a different output. So this one is a function. If we added the point 6, 2, then since we have a 6 and another 6 with different outputs, then it would be not a function. We're going to switch now to thinking about some graphs of functions or graphs of relations and try to decide if they're functions or not. For a function, each input can only have one output. So for each input value, there can be one output only. So that means, for every x value on our graph, we usually call that the x-axis, it can only have one height. So for something like this, maybe we've got some, graph that looks like this. It's okay if it has that same height multiple times. That's fine. The function can be how high it wants to be. That's still a function. For a graph, not a function would look like if we had a certain input value and it had multiple output values. So things like circles are not a function because this input has 2 outputs. So here are our first 3 graphs. We would like to figure out whether each of these represents a function or not. And we can use what's called the vertical line test, which you probably remember. It's a great way to visually determine if something is a function or not. So you can kind of just picture this vertical line and scan across your graph to see if that vertical line intersects the graph in more than one location. So for a circle, it certainly is intersecting the graph in 2 locations. And so this would be not a function. It fails the vertical line test. For our second graph over here, that also is not a function because you can see that it's that vertical line is intersecting the graph at more than one location. Not a function. And then finally, if you have a discrete graph, a discrete relation like this, where it's just a collection of points, you just have to make sure that there aren't any 2 points that are like stacked. So this one, oh, it's looking like it might be a function, but then we get to the end and all of a sudden we have those 2 points that are immediately above each other. So for the input 5, we have the output -2 and the output -5. So this one, this last one is also not a function. Here's 3 more graphs. We need to decide if these are functions or not. So again, kind of picture that vertical line scanning across your graph. So for this one, it is a function. For the next one, it looks fine. Oh, maybe a problem here. We'll talk about that. It looks like maybe where we might have a question on this graph is right here. So as long as your graph has an open circle below that closed circle or above, that's okay. That's totally fine. If they were both closed, that would be not okay. Or if they had some kind of overlap, that would also not be okay for a function. But if it's open and closed like that, that's fine for a function. So this would be a yes. Yes, that is a function. And then finally, we've got another little discrete relation over here with a bunch of collection of points. And if we scan through those, it looks like that each input does have only one output. So that is yes. All right, the next topic is evaluating functions. So you might see linear function here, you might see a cubic function, or you might see a quadratic function. Any of those types will come up in this topic. So I've got the 3 functions here, function f, function g, and function h. We first want to find f of -5. So we're going to substitute -5 into that equation. And if we calculate that, 6 times -5 minus 7 is, I think, -37. Be a little bit careful, especially if you're subbing in negatives. It's common to make errors with negatives. G of -1 is -2 times -1 to the 3rd power plus 5. So that is 7, positive 7. And then finally, especially with quadratics, sometimes people make errors. So just be really careful subbing in your negatives. If you're raising a negative number to a power, it's pretty important to group it, especially if it's an even power. So h of -7 is 94. Especially if you have a quadratic function that doesn't have a coefficient and you're subbing in a negative number, make sure you group it. This is perfect. What you don't want to do is leave off those parentheses because that will give you the wrong answer. Okay, so make sure you group it. Usually if there's a coefficient, we're going to naturally group it because we wouldn't put this. That's weird. But when it doesn't have a coefficient, sometimes people make that error. All right, the next topic is finding inputs and outputs of a function from its graph. So we were just practicing finding outputs from its equation. Now we're switching to thinking about the graph. So we're going to do this twice because it is one that people tend to make error on, usually probably because they're going fast and not reading carefully. Find one value of x for which h of x is 3. And then our second part is figure out what h of 1 is. So these are two different types of questions. This first one is giving us our output or our y value, which on the graph is the height of the graph. So if I'm trying to figure out my x value, I have to think about when does that function hit a height of 3? Well, the function is 3 high right here. So my x value is -2. So I've got a point -2, 3 on the graph. This is the output or the height. This is the input. In this case, we were trying to figure out an x value. So our answer is -2. For the second part, it says h of 1. Well, that is giving you the input. So we're figuring out, here's 1, the x value 1, the input 1. And it looks like the output of the function or the height of the function is about 1.5. And again, these definitely correspond to points on the graph. You just have to make sure you're finding either the x when you should find the x or find the y when you should find the y. So our answer here is 1.5. I'm going to do one more example of that because people just tend to mix up the x and the y's. Also, Alex is not consistent in which order it asks the question. So this one starts with what is g of 1? Well, again, that's your x value or your input. So the input 1 is here, and the height of the function is 2. So my answer is 2. For the second part, we know that the function has a height of -2. That's the output or the y value. And our question is, what is the x value? So I'm thinking about where does the function hit that height of -2? Well, it actually hits the height twice, right here and right here. It just says find one value of x, so we would not have to list them both. You would just pick one. So you could either type in 0 as your answer, or you could type in 3 as your answer. So we've got one of them occurring at 3 and the other one occurring at 0. All right, the next topic is domain and range of the graph from the graph of a piecewise function. So this is the entire graph of function f. We want to write the domain and range of f as an interval or the union of intervals. So we might have, a domain in two pieces, like 3 to 7, union, 9 to 12, something like that. Or it might just be in one piece. Just depends on what the function looks like. But we are writing it in intervals here. So when you're thinking about the domain of the function, you want to read it from left to right. You want to always read a domain from lower values to higher values, so left to right. So if I'm thinking about the domain of this function from left to right, the farthest to the left is -4, and that's a filled in circle. So I will start with a bracket and the value -4. And then the function goes over all the way until it gets to -3, and then it has this open circle. So it goes to -3, and I want to use a parenthesis because of that open circle. And then we've got this kind of huge gap right here where the function is not represented there. It's not in the function's domain. But I do have another piece. So we'll use the union symbol to kind of join those two parts together in the domain. For the next startup value, I guess, it's going to be a 1, and that's with a bracket because of the closed circle. And it goes over to 3. So we read it from left to right. We had a gap in the middle, and we really thought about brackets and parentheses for our domain, and we were focused on these numbers. Okay, now we're going to switch to the range. It's pretty easy to make an error on this range. Those two pieces of the function are very I guess, almost misleading, or they make it easy to make an error. So our range, we're going to use y values. When we're thinking about range, we read range from the bottom to the top. Always from negative values to positive values, or from lower values to higher values. So our lowest value on our function is this one, and it's at -5. It's a closed circle, so we want to use a bracket there. And then the function is represented all the way up until here. This is the highest point. That's also a bracket, and it's at the value 0. So a lot of times people will try to break this into two pieces, but it is not from -5 to -1 and from -2 to 0. It's not that. That is incorrect, because even though, we see those two pieces, there's absolutely not a gap. It covers everything from here all the way to here, and it covers everything from here all the way to here. There is no gap in there. So just be careful. Just because there's two pieces doesn't mean your domain or range will have two pieces. It could be just one piece or just one interval. I'll show you a graph that would have the domain in one piece and the range in two pieces. So this function, it's coming up. It's got a closed circle. It's got an open circle, and it continues up. So this is a function, I guess if I put some numbers on it, -1, 3. This is a function where if I was reading the domain from left to right, it doesn't even have a start value. It has arrows on each side. So it'd be -infinity to +infinity. But the range would have two parts, because the range has this gap that is not represented on the function at all. There are no output values inside that gap. So the range would be parenthesis -infinity to -1 bracket, and then our second piece would be from 3 to +infinity. And I was reading those numbers along, of course, the y-axis, because it is a range. So something like that, okay? So you may or may not have a union in either of those parts. All right, our last two topics have to do with figuring out the implied domain of a function for rational functions and for square root functions. So we're going to start with rational functions. Rational functions are functions that are fractions like this with some variables in both the top and the bottom. What it asks for on rational functions is find the x values that are not in the domain. Sometimes those are called excluded values. So the reason that functions like this have x values that are not in their domain is because we can't divide by 0. So since we can't divide by 0, we need to think about what values would make division by 0 happen, and those are our excluded values. So if we factor this, we get x minus 4 times x minus 4. So our excluded value, our number that x cannot be, is 4. Because if we sub in 4 here, we're going to be dividing by 0. Now this just happens to have only one excluded value because these two factors are the same. It might have, two different factors there. And in that case, you would have, if that was the bottom of the fraction, you would have x can't equal -2 or 3, and you would list them with a comma. And it tells you to separate them with a comma if you have more than one. All right, for square root functions, errors occur. I guess it's on this page. We have to exclude x values that make the radicand negative. Errors occur when we try to take the square root of a negative number. So if we're trying to figure out the domain of a radical function, we want to just think about the inside of that radical. The inside, which is called the radicand, the inside has to be positive. It has to be greater than 0. Positive means greater than 0. And it's also okay if it is equal to 0 because the square root of 0 is 0. So our inside has to be greater than or equal to 0. So I'm going to start with function v of x on the bottom here. I have the square root of x plus 7. So the inside, the x plus 7, has to be a positive number. It has to be greater than or equal to 0. So if I kind of get that x by itself, I get x is greater than or equal to negative 7. Now, if you need to, some people have a hard time writing intervals from an inequality. If you need to, draw a number line because that will help you maybe see how to write the interval for the domain. For this one, x greater than or equal to negative 7 means that the domain is going to be from negative 7 up to infinity. And maybe you're just really good with some of these functions and you can think about the graph. This shifts it back 7 units. So our function looks like this, a sideways parabola that got shifted to the left 7 units. So that domain from negative 7 to infinity really makes sense. For our second function up here, u of x equals the square root of x plus 1. Our inside is just an x, so we're going to set x greater than or equal to 0. Inside greater than or equal to 0. So there's nothing I really need to do to manipulate this equation. If you need to draw a number line to help you, you absolutely can. Greater than or equal to 0 looks like this. So if I'm writing the domain, it would be from 0 to infinity. Sometimes kids are like, but what about the 1? Well, the 1, if we were thinking about the graph, the 1 shifted the graph up 1 unit. So it would have the same domain 0 to infinity as the parent function root x because it got shifted up 1, not to the left or the right. So the domain is from 0 to infinity. All right, that's it. That's the topics for 2.3. Best of luck with that assignment. Let me know if you have any questions. Thanks.